So now we're going to look at one of the most important concepts from pre-calculus and calculus called evaluating limits. Now the method we're going to start with is not actually the technique you will usually use. It is not usually the go-to method for doing this, but it is great for explaining the concept of what finding a limit is doing. So the concept of what a limit is very important. The goal here of what we're doing is we're evaluating functions using numbers very close to a specific value. So in an example question, you'll be asked to do something with the limit as x approaches 2 as an example. But what we're actually going to look at is numbers very close to 2, like 1.9, 1.99, and even numbers like 1.999999. The closer you get to the number, the more exact you can be with your prediction of what happens when x equals 2. Now, the reason we do this is because sometimes you can't plug in a specific value. The most common example of this would be if you have a domain restriction because maybe you have a fraction. And in the denominator, plugging in x equals 2 might cause the denominator to equal 0. So sometimes you can't plug in 2 directly, but you could plug in a number like 1.999999 and get a really good idea of what would happen if you could plug in 2 instead. So let's look at the notation for what limits look like before we start talking about the process we're going to use here. This is the notation you'll see for evaluating limits. Usually you will see something like the limit as x approaches. Now instead of c, you're going to see some kind of a number there, like the limit as x approaches 3, or the limit as x approaches 7. So this number is going to change from one question to the next. The variable may also change. It's just telling you which variable to replace with which number. So the idea here is we're saying what number are we trying to get really close to for which variable. Over here it says f of x. Well, that's going to be where your function is. What is the equation that you're plugging into? So usually this is going to be something like 2x squared minus 3 over x plus 5. So you're going to have some kind of a function here being defined, and that's what we're going to take our numbers and plug into. So here's an example so that you can see it not in the general form, but with a specific example in mind. This is asking us to take 2 and plug it into the function x cubed. So we're going to replace all the x's with 2's and evaluate that number cubed. Now in this particular example, there's no reason not to just plug in 2. There's no problem with plugging 2 in. So whenever a problem says to do it by substitution, or if they just said find the limit, the easiest thing to do would be to just plug in 2 for x and then evaluate 2 cubed as 8. However, the reason we're going over this concept is because sometimes you can't plug in the number itself, like I said. So the process takes a lot of words to describe what I'm doing, but once you've gone through a few examples, it's honestly not that hard to remember the idea here. So if you're going to evaluate a limit by constructing a table, the first thing you should do is pick a number very close to the given x value, and then I'm saying start with a number that's less than the x number. So on that last slide, I would pick a number really close to 2, but less than it, like 1.9. So you would plug that into the function and evaluate it. So you would find 1.9 cubed and you would get a decimal answer for it. Be very exact with these decimals. Then you would pick another number between the last number we just chose, 1.9, and the given value of 2. So it should be even closer to 2 is what I'm telling you here. And then you're going to plug that number to the function and evaluate. So if I started with 1.9 for step 1, in step 2 I'd pick an even closer number like 1.99. And then you can repeat that process and keep getting closer and closer. You could pick 1.999, 1.99999. And the closer you get, the more exact your answer will be. Once you've done that with a few numbers that are less than the given x value, then you should repeat that process, picking a number very close to the x value, but slightly bigger than it. So again, for this example, I would also pick some numbers like 2.1. And then when I pick a number even closer to the given x value, for the next computation, I would test 2.01. or 2.0001, and you would keep plugging those numbers in and cubing them and getting new decimal values. Once you have your decimal values from the decreasing and the increasing numbers, you should be able to make a prediction about what would happen at 2. So here's our first example of looking at evaluating the limit as x approaches 1 of this expression, x squared plus x minus 2 over x minus 1. Now the problem here is we can't just plug 1 into this expression because then you ended up with 0 in the denominator, so your answer would just be undefined. But we're going to try to come up with a prediction of what would happen at 1 if there wasn't an undefined value for this number. So our first step is to pick a number really close to 1, but we want it to be smaller. So I'm going to start with the number 0.9. Then we want to pick another number in between 0.9 and 1, so we want to get even closer to this number. So next, I would pick 0.99. And then we want to get even closer still. So usually do this a few times from each side. So now if I want to pick a number even closer than 0.99 and 1, I could pick 0.999. Now let's do the same thing from the other side. Now let's pick some numbers getting closer and closer to the number 1. So I'm going to pretend that 1 is right here in the middle of my table. And we're going to pick numbers bigger than 1, but still getting really close. So I would pick a value like 1.1. Then we can get even closer. We can pick a number in between 1.1 and 1 by doing something like 1.01. And you could get closer still by picking the number 1.001. So we're getting closer and closer from the right side of the number and from the left side of the number. So you can imagine this like a number line, and then we're going to use that information to predict what would happen at 1 if we were allowed to just plug it directly in. So from this point, once we've identified the x values we're going to plug in, we're just going to be plugging these numbers into the calculator. We're going to evaluate 0.9 squared plus 0.9 minus 2, and we're going to divide by 0.9 minus 1. Your use of parentheses will be very important on these, or you could end up getting the wrong computation. So my first computation here, by plugging in 0.9 squared plus 0.9 minus 2, and then I hit enter, and then I divided that number in parentheses by 0.9 minus 1. In my calculator, I got the value 2.9. Now I'm going to repeat that process, but this time I'm going to plug in 0.99. So 0.99 squared plus 0.99 minus 2. I'm going to hit enter, and then I'm going to divide by 0.99 minus 1 in parentheses. So this time I got the value 2.99 by plugging this number into all of the x's. So now just keep repeating that process. I'm going to go ahead and plug in all 4 of these numbers to fill out the rest of my table so that I can make my prediction. So after plugging in the rest of the values by doing 1.1 squared plus 1.1 minus 2 and dividing by 1.1 minus 1, I got 3.1. Then I did the same thing with this number and the same thing with this number. So it's a little repetitive, but it's pretty easy to type these numbers into your calculator quickly. And usually you will start to notice that there are some patterns. If I had done another 0.9999, I would expect to get 2.9999. It looks like it's just adding another 0.9 every time. Same thing on this side. As I get closer and closer, it just seems like it's going to put more and more zeros in between the 3 and the 1 here. So now that I have my whole table filled in, this is nice. What I can do is I can try to make a prediction about what y should equal when x equals 1. Remember, I can't plug it in directly because that would be undefined, but it looks like these numbers are getting really close to 3 as I get bigger and bigger. And on the other side, as I get closer and closer from the right-hand side of the number line, it looks like I'm getting closer and closer to 3. So since these numbers both seem to be approaching 3, I'm going to say that the limit as x approaches 1 of x squared plus x minus 2 over x minus 1, I'm going to say that the limit of this is equal to 3. That is the answer to this original statement. Sometimes your numbers may not match from the two sides, and we'll talk about that later, but for all of your examples on the first assignment, you should see that the number from the left is the same as the number from the right. If you get an example where you can just directly plug the number in, it's a great idea to go ahead and do that anyways, just to check your answer. But I am still asking you to create a table to make sure you guys understand the concept of evaluating a function at a value of x with numbers really close to the given number, just in case you can't use the number itself. So that's it for the notes. That's how to evaluate a limit by constructing a table.